Okay, example 3. Coefficients other than 1. So far we've just been working with um, stuff like a plus b squared. Now, how we're going to adjust this to make it more interesting is what if it was 2ab plus 3 or 2a plus 3b that was being squared. Well, you have to remember it's this whole chunk that is the beginning or first term of the binomial. So it would get squared plus 2 times it times the other piece, the 3b, plus 3b squared. And it'd all be in parentheses. So you'd get some very large numbers. And that's something that's going to happen here is you're going to get very large numbers as coefficients, and they're not going to be exactly the same as Pascal's triangle. Because we've got this 5 and 4 that are in here, actually it's a negative 4 that's in there, it's going to kind of mess things up, including sign changes. So we have to watch out for all these little things. And the whole idea here is to be systematic. You're going to want to make sure uh, that you're using the correct combinations, uh, as in the binomial theorems tells you to. And you're going to want to use parentheses around like the a to the 7b or 7 minus 2 and the b squared things. The power parts, I guess we could call them. The power parts. You're going to want to make sure you use parentheses around all of those and set it all up and then take your time on each term and calculate it out. So we've got ourselves a fourth degree expansion here, which means we should expect 5 terms. It's that 4 plus 1 that we're expecting to give us the 5 terms. Okay, so 4 choose 0. That's going to be our very first term. 4 choose 0. Okay, just getting my calculator set up for it. I know it's 1. All right, the a part is 5a, and it should have an exponent of 4. The b part is negative 4b. It should have an exponent of 0. Plus 4 choose 1. The 5a and the negative 4b are still there, but 5a is now down to 3, and the negative 4b is up to 1. Plus 4 choose 2. 5a is down to 2. Negative 4b is up to 2. 4 choose 3. 5a is down to 1. And negative 4b is up to 3. Plus 4 choose 4. 5a is down to 0. And negative 4b is up to 4. Okay. Now, each one of these things I'm going to be very careful about calculating them. Though the first thing I might do in my calculator by hand is write out what the choose notation is, because that's easier to calculate. So 4 choose 1 is 1. And I'm just going to line it up. Or, sorry, 4 choose 0 is 1. 4 choose 1 is 4. So you can see I'm just kind of lining it up there. 4 choose 2 is 6. 4 choose 3 is 4. And 4 choose 4 is 1. Okay. So it's nice not having an eighth power expansion. There's a lot less to calculate there. But now what I have to calculate out is multiply this by 5 to the fourth times a to the fourth, and negative 4b is just 0, so it's going to hang out there. 5 to the fourth. What is 5 to the fourth? 625 times 1, so my first term here is 625 a to the fourth, because negative 4 to the 0 and b to the 0 are both 1, so I don't care about them. Next up, we've got 5 cubed, a cubed, negative 4 to the 1, b to the 1. Now, that means I'm going to have a cubed and b to the 1. But let's figure out the numbers. Negative 4 to the 1 is negative 4 times 5 cubed. Oh, well, let's just do 5 cubed. Oh, it's 125. So we have 4 times 125 times negative 4. 4 times 125 times negative 4. And we get negative 2000. A cubed, b to the 1. Plus 6 times 5 squared times negative 4 squared. So that's going to be my number of coefficients there. And I just have a squared, b squared at the end. So 6 times 25 times 16 is 2,400. A squared, b squared. So you can see I'm being very careful here. Each time I'm taking the combinations and then the coefficient parts with the correct powers. 4 times 5 times negative 4 to the 3. And of course I'm going to have my a to the 1, b cubed down here. So negative 4 cubed is negative 64 times 5 times 4 is negative 1,280. A to the 1 b cubed. And the last one, we have combinations 5 to the 0 and negative 4 to the 4th. So negative 4 is 256. Negative 4 to the 4th is 256 times 1 times 1. So we're just going to say plus 256. A's are gone because we have a to the 0 there and b to the 4th, so we just have b to the 4th. So you can see it's all more about making sure that all the little parts of the binomial get multiplied out, of the coefficients.